So it's an absolute pleasure having Michelle Carey and Mark Gabbitus from IMDEX here today. As a fellow supplier to the industry, they've been wonderful friends and role models to me. So I'm thrilled that they're here today to chat about managing your sensor data and using AI to turn data into information. So it's going to be a great session. Please use the chat. You'll have the chance to jump off mute at the end and have some discussions at the end of the presentation. And I hope you all enjoy it. So thank you so much to both of you. It's awesome that you're here.
Thanks, Jess. Obviously, when you rang and asked me to come on, I was always going to say yes. I think what you've been doing is super cool, but I'm not going to lie. There was some domestic competition that played into my decision making. My husband had already been on GeoHug, and so that really strongly motivated me as well to make sure that I had my turn to show him up. And I found out earlier this week that he's coming on again. So for those of you who one Carey Beresford isn't enough, my husband is apparently on this afternoon. So you can have both of us in one day, which, you know, wow, what a bonus. And then obviously once I decided that I had to do this to compete with Steve, my next thought was, you know, obviously I needed to dob Mark in to help me. Now Mark, I know, thinks that because I'm lazy and wanted him to do all of the actual hard work. But really, at IMDEX, we're all about career opportunities, Mark.
Growth.
It's all about personal growth. That's something that Mark and I talk about all the time. So that's what this really is. This was a growth opportunity for Mark. And maybe a little bit more seriously, the stuff we're going to talk about today is really stuff that Mark takes carriage for on the day-to-day, whilst I'm wandering around waving my arms. So to be honest, I would have felt pretty cheeky if I had done it without him. So what we actually want to talk about, as you said, is all about the collection of data, how it gets turned, you know, using AI, which is one of our favourite buzzwords now within the industry, how it gets turned into information. And in particular at IMDEX, we've always, or for a long time now, been about how that happens in real time. Kind of reflecting on this a bit last night, it's been quite a long journey for IMDEX. We've been trying to do this for a really long time. And for me personally, if I count the time that I was with ioGAS before IMDEX bought us, which is about 9 years ago, then it's been a journey that's more than 10 years long. And Aaron, seeing you there on the call, the other thing that, you know, comes to mind is the DTCRC and that Lab at Rig project, which is really some of the early ventures we had into creating assay data at the rig in real time and feeding it up. Even that is nearly 8 years ago now. Matter of fact, a little more than 8 years ago that we started that project. I've got an easy way to keep track on that one because my son was born in and around the time of the project, so I can always keep track. So, you know, the stuff we're going to talk about today, it's a really long journey, actually. Sometimes I think it feels like we're only just begun, but it's definitely worth reflecting, I think, on how long some of this stuff has taken to come to reality. So if you want to bring up a slide, Mark. Now, this is a slide that I actually use quite often to talk about what geologists are, and normally I use it to talk about what geologists might become when we become, you know, as we become increasingly data centric. How much does this change? And the other thing that I quite often talk about is the cultural shift that some of this implies. You know, in particular, some of those Pierce Brosnan type flicks and a geologist standing up. Yeah, Mark thinks he's Pierce Brosnan. I don't know how I get him to realise that's not true. I'll take chat commentary on advice on that. I even wore a
green shirt specifically to match that photo today.
All right, that's not helping you as much as you would think. Yeah. So yeah, well, you know, advice from Mark on how to really become Pierce Brosnan, definitely welcome on the chat line. But the reason that I wanted to bring it up today was actually to reflect a bit on, you know, we think that that geology isn't changing that much. You know, I think we sometimes almost bemoan the fact that the life of a geologist might feel pretty similar to what it did, you know, 10 or 20 years ago. But actually, I don't think that's true. And we'll talk a bit more about that as we go through. But, you know, Mark's got here a bit of a collection of some of the things that were the only tools we had at our disposal, right? And not to say that these things aren't still incredibly valuable and useful to a geoscientist, but really this is all we had And really the only things that we had as recently as 10, 15 years ago, it was what a geologist could see and touch, and what a geologist could see and touch after they'd bashed a rock open. So again, I think it's quite a good reflection to, sometimes I think as an industry we complain about the progress we haven't made, but it's also good sometimes, I think, to think about the progress we have made.
Yeah, it's been a long journey for myself, coming to Australia in the 90s and getting shoved on a rig out in Wiluna in 45 degrees and just given a hand lens and a brown rock. I'd grown up in England looking at fresh rock and having to that challenge of having to relearn to be a geologist and having nothing to help me, just having to essentially start again, and how hard that is for even people coming out of university in Australia. They're not trained in the right way to actually enhance their geology knowledge. And it just comes down to experience and skill and time. And, a lot of the stuff we're trying to do is shorten that time frame for them to understand stuff.
And probably also about, I think picking up on one of your other themes is how do you help geoscientists? Now, sometimes some of the more militant conversations that Mark and I have is how often should you just replace what a geoscientist is doing with sensor data going straight through to answers, and how and when in the process is it much more logical to just provide data in a really consumable format for geologists to use. Mark, always I think takes the position of helping, and maybe sometimes on my more cynical days, or maybe my more confrontational days, I'll take a path that's more like maybe there are some of these tasks where a geologist just doesn't need to be as heavily involved anymore. I argue about this with my husband as well, as some of you on the call might guess, quite frequently. Okay, so maybe let's talk about some of the things that have changed. Oh, actually, before we do that, sorry, let's maybe put a bit of a framework around it. So this is a slide we actually first created when we were talking to Google. So we had maybe it was about 3 years ago, again, back in the days where travel was possible, we went across to San Francisco and really talked to Google about the challenges of geoscience and why they might want to be part of what we do. You can go back a slide. And we had to kind of try and think about a way to describe geology to them so that it made sense. And so this was really what we came up with this idea of talking about the rock as 4 components. And I really just wanted to use that as a frame for the way we're then going to talk about other stuff. But maybe, Mark, I'll hand over to you to describe the 4 bits of the rock and how we've played in the past and some of the things that are starting to happen.
I think as geologists, we tend to focus on our area. So we understand minerals. We spend a lot of time looking at the minerals. So again, that's where the hand lens comes in. It's where the hammer comes in. It's where we get our name from when we're licking the rock. We get into the rock and we look at the minerals. We can study the structure and the texture. So we can use old tools like this and compasses, or we can start to use a bit of technology like the IQ logger to really understand the structure of the rock. And we're very comfortable with that area. We get a little bit funny when we start getting to grade. We send samples off to the lab and we spend a lot of time analyzing that data. But we often forget that 4th piece, and that's the location and how important that is. And that's really where IMDEX brings a lot to the story, our survey tools, our core orientation tools. So making sure that we're not just talking about the physical and the chemical attributes of the rock, but also the spatial attributes of the rock is really important. So that's why we broke it down into 4, and that really helps us and people that we work with understand what we're trying to do is bring in those 4 components together. Obviously, the ultimate endpoint of this is just to be able to say, when you're here, the rock is this, but that's the future, I guess.
Cool. So, and I think, harking back to some of the early commentary, the traditional way, and the way that actually we had no real choice, that the rock was defined was, yeah, you had some sort of survey tool. You would eventually get your sample sent away to the laboratory to get some of those assay components and some chemistry, and then the rest, it was really reliant on visual observation. But that's shifted actually quite a lot over the last, in particular, 10 years. Probably the first shift, and again, Aaron, this is a space that you played in really heavily, was the introduction of portable XRFs into our industry. And that's actually, they're close to ubiquitous now. And again, I think that's something we don't always think about, the actual massive shift that's introduced, and actually how far those technologies have come over their lifespan, over that 10 to 15 year period they've been part of our life, where actually something that we talk about a lot these days is the sensors themselves that sit in those portable XRFs, that they're as good as the thing that you'll see in a laboratory doing lab style assay. And really all it comes down to then is how they get used in the field. Obviously some of that sample prep, and those of you who know IMDEX know that preparing samples well is something that we've always been pretty passionate about. It's the geochemist in us. We've got a surprising number of geochemists tucked away in the building.
There's a picture of one there.
Yeah, there's Fred, who's one of them, sitting there. But, and even, you can see here in that picture, Fred's using a portable XRF in a what we call the barbecue, or a system that at least allows the sample to be presented in the optimal possible way. So, and I think the XRF story, and we'll dive into this a bit more, is quite consistent to some of the things that we would see across all of the technologies, is that the actual technologies themselves have come a long way, but then it really comes down to how they get used in the field and how we optimise their use in the field, which is still, I think, some of the challenges that the industry faces, and that obviously we work really hard to try and solve.
Yeah, we still see a lot of people just, point and shoot, and it's got a place. Pointing and shooting, it gives you an answer, but you're only getting an answer from the top microns of the rock and the bit that you pointed at. So you have to be really selective. So that is a potential problem. Yeah. But it can be useful as well. It just depends how you're using it and what context you're using it in. And I think people get confused sometimes about the context and the value of that data.
Yeah, I think that's true. And, and I think the other thing, and again, linking through to our data theme, and we'll definitely explore this a bit more, is that the data challenges that using, instruments like this in the core farm create mean that quite often what you see people do is not just point and shoot, but point and shoot, read the number off the gun, use that to inform the decision they make in the field, and then not actually store and get the maximum out of that data. So we get some value out of doing that, but we stop ourselves from getting all of the value. And then I think, one of the interesting consequences is we're almost, I think, now going, well, maybe XRFs and point and shoot isn't the way. Maybe some of these scanning technologies that are starting to appear in the market, does that become the solution instead? So you can see we've included a picture of the analyse unit there. We love our Swedish friends. I'm not sure whether either Annalie or Michaela are on the call today, but obviously they're one of a cohort of people who are developing really interesting technologies in this space. And I think a bit like Mark's commentary around portable XRFs and the mode they get used on, these sorts of core scanning applications, and they're all different. Analyse are based on, they've got really heavy use of photography, and also an XRF running a scan down the core. Obviously, you've got things like core scan that do, much more really very detailed work using hyperspectral as well. There's things that are just cameras out there. There are some technologies appearing that use libs as part of their approach. So, there's an amazing amount going on in this space. And you have to think that they're going to have their place as well, both in core farms and maybe in laboratories. And one of the things that we think about a lot is, what is going to be that future between when people use handheld instrumentation and when people use some of these scanning applications?
Yeah, I mean, if you're drilling 1,000 meters hole and you think you're going to put every one of those core trays through a scanner, you're kidding yourself, right? You're just not going to get it through in time. So you really need to narrow down your view. So how do you get to position where I'm only putting the interesting core trades through a scanner because the output's fantastic, but I don't want to put every core tray through. So that's where that synergy between the handheld tools or some analytical tool that can help narrow your view, so then you can just send the really interesting things off to these scanners, is where we think the future is.
And again, if you wonder the sorts of things that we talk about or argue about all the time, that's definitely one of them. And really that idea of, are these scanning technologies going to take over the world? If so, which one? Is there a reason to think it'll just be one of them, or could it be a few of them? And as Mark says, really, is that going to happen at all? Given the pace at which they can scan, is that even a realistic expectation? Or are we going to come up with these workflows that are much more like quick and dirty, using one approach, some sort of middle ground where you use a scanner on the stuff that you really care about? And then, of course, the final question that leads to is, what's the role of the laboratory and all of that? Obviously, the JORC bankable grade still sits with them. Is that their natural home at the end of all of this? Again, if there's any people, guys, when we were doing that lab at Rig project, I think the laboratories watched with quite a level of concern, thinking perhaps we would cut their lunch. We were always at pains to say that we thought that the two were really compatible techniques, that one was about real-time decision making, was about giving fit for purpose data to geoscientists in the field, and the other was about bankable resources. But nonetheless, it's going to be interesting to see how that plays out in the world. And then, the other two photos that sit on here are one of the other spaces, the measurement of structural features. So you can see the IQ logger there. Mark, there we go. There's my hand model showing off an IQ logger. Obviously, this is one of the ways that we look to do this. And obviously, it replaces beautiful pieces of plastic. This is actually also one of our products, ironically. So we've made ourselves obsolete, or at least we're trying to, by moving things into a semi-digital world by using an approach like the IQ logger, where, the way we think about that is that the collection of the data is still controlled by the geoscientists. They're actually still doing the collection, and indeed, in a perfect world, doing the interpretation whilst they're wielding the rat, as I like to call it, in the field. But, that's one approach. And again, a little bit like we just talked about for scanning technologies, on the other end of the spectrum, there's all sorts of players coming out. The photo, I think, comes from the Data Rock guys, who, again, we think are doing some really cool stuff, where people are using image data, either photography or LiDAR or a mixture of both, to actually use AI to define where structures are in the core. And again, our suspicion would be is that the world might end up with a meld of both of those approaches, right?
Yeah, I mean, you can't do everything from photography. You can only measure what you can see on a photo. And there are plenty of examples of structures that are hidden. So sometimes you're just going to have to touch a rock, and sometimes you just want to touch a rock. And again, this is our continuous argument, right?
Yeah, that's right.
Argument, bickering, whatever you want to call it.
Bickering, let's call it bickering.
Where I think that the geologist still needs to touch a rock and be involved, make decisions, but it's never the geologist that concerns me, to be honest.
No, they're not who keep you awake.
They're not the ones that keep me awake at night. But we'll get to
talk
them.
about them.
We'll get to those guys later.
Yeah. All right.
Yeah. Let's flick over.
Yeah, let's flick over.
Yeah.
So that's kind of the what goes on in the core farm side of things and how that's starting to shift. Now, of course, the other thing that's changed massively, actually, and probably what dominates a lot of conversation, I think, now is data science or AI and the role that it plays in the day-to-day of a geoscientist, and how data science is best done. I'm sure almost all of you on the call will have been involved in discussions that look a bit like, do you need geoscientists to learn how to do data science, which of course is a lot of what ioGAS was sneakily always trying to do for all these years? Or are we going to take data science professionals and try and teach them enough geology? Or are we going to try and, find these perfect little marriages of people pairs of people who can do things together? I think here in IMDEX, actually, we've probably got both things going on. We've got people like Fred who are geoscientists first, but have become data scientists over time. And to be honest, that's probably, for a geochemist, not that much of a shift.
But we've also hired data scientists and we're turning them into geoscientists.
Exactly. And it's quite fun to watch that happen to them, to be honest. I think their heads sometimes think they're going to explode, but it's definitely real. And, and again, if you look at something like the Solve Data Rock guys, I think they've got a similar blend, right? Where they've got Amazon trained guys who really understand the fundamentals of data science. And then they've got super geeky geologists who really know what data science, what geology should be and how data science should be applied. It's fun
being in meetings with those guys because they're two very different people in the room.
It's very much the case.
I should point out that this is old ioGAS. This is probably 9 years ago version of ioGAS on the left and a newer version on the right. I should have sneaked it in, but I chose not to. I got a photo of you from when this was out. I chose not to because I thought I wouldn't get sacked.
Yeah, get sacked.
Michelle had long red hair down to here and she looked so young when that was out. But that came out. We had our 40th last week, and that photo came up on the screen.
It was great. Really loved it.
Yeah, the picture of Dave was probably more humorous, but
I think that's a good point, actually. For those of you who know Dave Lowy, yes, I might look implausibly young in that photo, but he looked ridiculous.
Yeah.
It's time to bring it back in. It's overdue.
The long hair.
No. I don't know whether anyone have noticed. I've had to resign myself to being old and white. But I think the journey that ioGAS has gone, actually, I think really reflects the journey of the industry in this space over that period of time, right? The idea of a software program being able to make ternary diagrams and some of those lithology classification diagrams for you was a big deal 10 years ago. But now if you go and delve into ioGAS, then it's all, really quite high-end data science techniques like wavelet tessellation. You can see there's decision tree type frameworks in there. There's principal component analysis. There's all sorts of things, and increasingly so, right? And we quite a common discussion. Lots of people will be like, I've done such and such in Python, I've done such and such in R. And you're like, well, actually you could have just gone and done that in ioGAS. And the philosophy, the reason we normally say that, by the way, is not because we just want to make more money out of software sales, although that's always a thing, but it's because a lot of the effort that went into ioGAS was about how do you keep geologists out of trouble? If you're going to turn a geologist into a data scientist, how do you do it in a way that they can't come up with crazy answers to kind of guide you down a safer path?
It's also that data handling. And we haven't really talked a lot about that data. But, the one area where Michelle and I do agree,
the
one area where we agree is, how much time geologists spend playing with data. I know, back when I was working, when I had a real job on a mine, and you'd get, 20 CSV files from the lab every day, and you're trying to push that into your database, and you're checking your assays, and you're checking your QA/QC duplicates and all that sort of stuff, and that would take up 20% of your day. And I look at it and go, right, well, if I can take that off a geologist, and put the geologist either in the field looking at the rock, or have the geologist in gas or what their GMP system is analysing the data, that's where the value is.
I think, it's true. And, I talk about the Hub IMDEX Hub IQ as plumbing a lot. And it's the reason I do that is plumbing's not necessarily sexy, but it is extremely necessary. And it really speaks to what Mark's talking about, is a lot of the stuff that we've looked to do over the last few years has really been about trying to create those plumbing layers that gets data from the field into where people want to use it to do, data science type approaches. Because I think one of the brutal realities that we don't spend enough time on, we don't acknowledge enough, is that you can only really do super cool data science, and you certainly can only really do super cool data science in a repeatable way if the data's all nicely handled for you. So
if you have to go and get your CSV files, format them, put them into Jupyter, do all your analysis, pump out your reports. You've had to spend a year learning how to use Python or R, and you can just do that at the touch of a button in a repeatable way in GAS. I know which way I'd rather do it.
So this might be an apocryphal story, but I'm going to tell it anyway. And it goes to one of the scanning technologies. I won't say which one, and it kind of doesn't really matter. But someone told me the story that they'd worked with one of the scanning groups, and they'd done this amazing study over 3 to 6 months, and had created all this data, and then they'd done a one-off consulting job that gave them all these really beautiful looking pictures, and it was all looking great. And it's like, yep, this is actually something we should adopt into our day-to-day. But actually then the whole thing fell over because they couldn't figure out how to get the data off of the hard drives that it was on at the scanning, the scanning company's office into their acquired database. And it seems like such a boring thing to trip it up, but they spent 12 months trying to do it. And then in the end, they just go, maybe we're just not going to adopt that technology after all. And it's stuff like that if we don't change that, then we're actually not going to move forward.
People lose their jobs, people lose respect for the industry or for our industry.
They think we're Muppets.
Yeah.
That's true.
Yeah.
Cool. All right. I think you flipped one.
Yeah, there you go.
Yeah. This is a desktop snap of AI Sirius, which is a product that Auspec made. But I think the reason that we just wanted to bring it up is that I think it exemplifies the intent of some of these data science type workflows. To Mark's point about how do you turn something that otherwise is kind of raw information into something that's immediately usable by geoscientists. So what AI Sirius does is it takes the spectra from an NIR and it turns it into mineralogy and features that a geologist can use. And it does that, at the moment, it does that in a kind of semi-autonomous fashion that takes a couple of days potentially, but we're right on the cusp and actually have some customers using this in prototype phase of that happening in real time. So again, what this means for geoscientists as they're standing there logging core is that they can use their Halo or whatever instrument that takes their fancy, an ASD scanner or something, and they can get mineralogy information and they can get it straight away, and they can use that to guide the way they do their logging. And it's those sorts of approaches and how you streamline those sorts of approaches that actually we spend a lot of our time thinking about.
Yeah, I think, for me, again, going back to when I used to log core, if you think about, you're looking at a rock and you've got some white mineral and you've got, no idea, you're guessing, you're hoping that you've guessed right, and then you send it off, you have to send it off to a laboratory and 6 weeks later you get an answer. If I could have pointed a portable NIR at it and zapped it and got an answer right there, that would have helped guide my decision making. That's really what it's about. Do I drill deeper? Do I stop the drill hole? Do I sample this piece of rock, or do I just put it back on the shelf? All those really simple decisions.
Or as we talked about, then hand it across to go and get the whole meter scanned and get really detailed.
Although they didn't have them in 1995.
No, 1995. There you go. Everyone who's been wondering how old Mark really is. That's good. I think we all probably could have guessed from the haggard eyes as well. Good. I'm saying that because actually I graduated a year before him, so I have very little leg to stand on this one. And then this is probably the holy grail, really, Mark, is, helping geologists to log is one thing, but helping geologists to start creating their models in real time.
Yeah.
That's really where it all comes together.
Yeah, I mean, I've spent a lot of time in this world, as most of you know, and, you go to a site and you see how they do their modeling, and it's very, it's still stuck in the same techniques we were using in Vulcan, back in the 90s. Yeah, you've got leapfrog and yeah, you've got micromine with some implicit functions, but the steps are very much the same. So we want to speed that up, go to that real-time decision making, and this isn't just on the resource side; it's on the mining side as well. If it's taking you a year to rebuild your resource model or your grade control model is taking several hours, kill me now. I need to make decisions, and I need to tell someone to do something, whether it's a driller or a digger operator or at least just, I want to know.
Yeah.
So this is from Mine Portal.
Yeah. So obviously, what's something else that people might know about IMDEX is we're quite acquisitive. We develop a bunch of stuff in-house, but we're also always looking for interesting opportunities out there. And these guys have created a cloud-based modeling software actually. And for us, that's an opportunity to maybe do things a bit differently. By things being in the cloud, this idea of real-time workflows really starts to open up. So again, we don't necessarily think this is going to change the GMP that people use. Heaven forbid people probably are still going to use Vulkan. But what does some of those middle steps look like where people can actually see what they're doing in 3D, create a model in real time and make decisions? It's always the same thing for us. How do you make decisions faster? How do you really shift the way geoscientists are doing their jobs?
Yeah, 100%.
Okay.
But reality.
That's right. So as I said, for us, honestly, we love talking about the cool things that can be done once you have data in the right place, but this is what the reality looks like.
This photo was sent to us by a customer. I think it's JDH Exploration. This is how they do this today. So he's got a Olympus Banter there in the barbecue. Off to the one side, you can't see it. He's got a halo. He's got ioGAS and the hub on that laptop in the middle. He's got his geologist notebook where he's been writing stuff down. And what this guy's got on the left-hand tablet, that's linked to ioSirus. So he's got that picture that we showed before of ioSirus. On the one on the right, he's got pXRF Connect, which is one of our packages. And then in the middle, he's got gas and hub. And he's looking at this data across 3 screens and his notebook and trying to join it together to start making these real-time decisions. So this is what reality looks like today. This is state of the art almost.
That's right. This is what, this is the fruit of 5 or 6 years of quite hard work, and it still looks pretty inelegant, right?
So yeah, so I mean, we're very focused now on how we streamline this. Now that we've acquired ioSirus, obviously we've got ioGAS, we've got the hub, we've got the pXRF Connect, we've got the IQ logger. How do we bring all this together into a single place so the geologists can start making these real-time decisions? And those real-time decisions might be send this sample to Analyse or Core Scan. We're happy for that to happen. Yeah. We want that to happen. We want people to be using that tech because we believe that the data that comes back and then we can use
better choices.
Yeah.
So I think it's probably a really important point to make. We've pretty deliberately smattered through here, other people's stuff as well as our own, and it actually speaks to a principle that's really important to us and has been for a long time, is that one single provider is never going to be the answer to everything. There's always going to need to be a whole community of people creating these sorts of technologies and creating some of the AI answer products off the back. That's increasingly a really rich ecosystem of all sorts of cool people doing all sorts of cool stuff. And really what we think about and talk about a lot is how do you make sure that that's all coming together in a state-of-the-art way so the geoscientists can do their job properly. So yeah, I mean, I think the point here is that even our own tech looks like this at the moment, and we talk a lot about how do we, and also other people, how do we work with other people to come up with something that actually allows the geologist to do things in a better way.
Some of that's really boring.
Really boring. We know this. We get fired up about it because we know what it enables, but the brutal reality is it's quite grim and dull.
I was on a panel last week where Michelle dobbed me in.
I did. Another career growth
thing where I had to talk about invisible infrastructure, and I had to look up the word, but it's just what I've been doing for a long time. It's databases, it's cloud infrastructure, it's APIs,
comms networks,
standards of data transfer. How do we bring all that together so that this guy here doesn't have to take 2 USB dongles, a CSV file import, an acquire database, pull it all together to be able to make his decisions in whatever GMP he chooses to use, right? That sort of stuff, that
It's really,
that really bothers me.
I know.
And we're still there.
I know.
You know, here we are 22 years later, and we're still doing the same old crap that we were doing back then.
So, you know, the one that always gets me is the USB file at the drill rig.
Yep.
Although I think actually there is something that I think is even worse. And I don't know, I'm sure some of you on the call have seen people do this. It's actually a driller taking a photo of a piece of paper that has the result on and then just texting the photo to the geologist. You're like, really? Really? That's still what we think data transfer looks like.
Yes.
And that's probably a pretty good segue into what really keeps Mark awake at night, which is, you know, we've talked a bit about how the life of geologists has gotten more complicated and we're using, you know, more and more sophisticated sensors. But actually, our expectations of what the drillers will do for us have lifted a lot over that same period of time. You know, just as a simple example, the sorts of north-seeking gyros that we put in the hands of drillers in the oil and gas industry, they're still only used by quite high-end survey professionals. And certainly, you know, 5 years ago, that's the only way that a tool like that would be used. But now it's absolutely routine to hand that over to a driller. And that's not easy, actually. That's, again, probably the other thing that we spend a lot of time trying to get right. And it's probably the other area where, as geoscientists, we need to be really aware of the expectations that we're putting on our drillers.
I took a few of our engineers up to a site a couple of weeks ago that actually never been on a rig. They were young new engineers.
Young, impressionable engineers.
Yeah, it's very impressionable. And for them to see the reality of how things like the sprint here are used by the driller and the workflows that they have to do, they were blown away because they only see it on a test bench, they see it in a lab, and then to actually see a driller doing it and you know, these guys, you know, banging these things around and throwing them on the tray and hitting tubes with hammers, and you know, grease and dust and water. They were blown away.
Yeah.
So, you know, that was great to be able to show them, but we have to think about that in everything we do. You know, what do we build? What do we make? Can they actually use it? Is the workflows right?
Yeah. And I think the other one too is not only can they use it, but does it interfere with what they think of as their day job? So, you know, drillers, we pay drillers by how many meters they drill in a day. So probably rightly as a result, when you then introduce workflows that mean they have to use some fancy sensor so a geo can have data, if you do that in a way that's really disruptive to them or in a way that then you either have to change the way your contracts are structured. That's obviously one way to solve it. But really what we do is just make it as seamless as possible. It's, you know, perfect case, the sprint, that survey tool runs faster than a traditional survey tool. So they're winning as well. And that's kind of our perfect world, is when everybody feels like they're getting a benefit out of this. And you know, if you cast your mind back to one of the photo we showed that had the rat and a scanning unit and the data rock AI approach to doing structural analysis, the brutal reality is all of them rely on core orientation, which again, the actual core orientation tools, those are pretty clever and they don't really screw up that much. But sitting in the middle, we have drillers and coloured pencils. Drillers and coloured pencils. You know, you can see here, I mean, this is from I think it's from the All Find blog. I stole it shamelessly from one of their blogs. But, you know, look at the site. How do you find where the bottom of core is from that dot? I mean, there's almost a 20-degree radius of the core. So you've got the potential. So, you know, you're going to pick the middle, right? And you're going to put a mark here, but did it hit there and bounce across or get smeared? You know, it's like, you know, getting a lipstick kiss from your auntie at Christmas, you know, it's horrific. But where does it go? And this, you're making massive decisions on. Right? You know, where is my fault? Yeah,
where is my vein?
Mind, right?
Safety of your mind. Yeah. So these are the things that keep me up at night. And how do we enable the driller to not be able to make this mistake? Yeah. Or at least when they do make these,
that it's visible, right?
It's visible. People understand it.
And that's that quality thing that we talk about all the time. Yeah. It's, you know, particularly if you're going to entrust data collection to drillers the way we've all done, because it just makes sense to do that. They're there. Why go and get, you know, an additional crew to go out there if you can get drillers to do it? But how do you put the safeguards in place to make sure that the data that they create for us, that it's really, that we base critical decisions on, how do we make sure that it's fit for purpose? That, again, stuff that keeps us up at night.
Because then we're throwing a digital laser-driven solution, a laser. That's why it's like,
yeah, that's why we like it so much. It's got a laser.
Yeah. But you put that and you're taking really accurate readings of structures, and yet that structure is related to a line that's related to that dot.
I know, killer.
Kills me. But it has got better.
It has. And I think it's just, and just probably our last slide, and really to round out that point, is that's the challenges that some of this new tech introduces for drillers. But it's probably worth calling out that, you know, again, the life of the geologist has changed in this space in ways that we don't necessarily acknowledge. And probably back to one of your points, Mark, it's not stuff that we're trained how to do in universities either, which is, you know, the sorts of survey tools that we use now. It's, you know, Eastman discs, and again, showing my and Mark's age.
I'm sure John used to look at it through his hand lens.
You know, hand over from a driller to a geo. Here's the disc. What do you know? Plot that up on a section and make sure that it lines up with all the rest of them. So again, you know, these continuous north-seeking gyro tools open up the ability to do actually quite a lot more quality control, but interpreting that data is not something that we know how to do as an industry. So educating people on what that means, what's good and what's bad, and actually brutally, again, this is one of these spaces where we talk about automation and removing the geoscientist a little bit, is how do we guide the decision-making process around quality? How do we say, actually, we've done a first pass across this data and we can tell you that this survey has failed and this is why. Maybe it's the tool, maybe it's the driller, maybe, you know, there's all sorts of things that could be the reason why, but actually just to put that the information into the hands of geos for a really simple decision-making process, which is this good or is this bad?
Oh, I mean, you know, when you go and look at JORC reports, they still sometimes say, you know, using a reflex camera.
Yeah.
And that just gives me chills, right?
I know. It's still really common for it to be called a camera. And you're like, that's probably a $200,000 north-seeking gyro you're talking about.
Yeah. And yeah, we talk to geologists a lot, and they don't get taught this at school. They don't get taught
I didn't.
to learn how to interpret surveys. Why would they? That's what surveyors are for. But they're expected to make decisions on what tool the driller uses, and it can be just a reference tool. It could be a
magnetic tool,
magnetic, or a really high-end north-seeking gyro. And there are a few of those. Which one do you choose?
Yeah.
What's right for your situation?
Yeah. Right.
So that's part of our world now, is helping to retrain the industry and what that means and what's good.
Yeah, that's right. What good looks like.
Yeah.
So Jess, I think that's the end of our little song and dance.
Thank you so much.